Hey there, Ravens. Welcome back. We are working on Ideal Gas Law homework problems. All right, here we go. What volume, right off the bat, there's my question mark, what I'm looking for. What volume does 4.24 grams of nitrogen gas, which is N2, and I know I don't want it in grams, so right away I'm going to do my math to convert grams into moles. Okay, 28 is because it's N2, right? Nitrogen is one of our diatomics. And 4.24 divided by 28, hold on, let me turn my page over here. For my notes, we are going to get to, it'll be 0.151 moles. Okay, and that will equal N of a gas occupied at, so temperature is 58.2 degrees Celsius, and we know automatically do 273, and when we add that to 273 it comes out to 331.2 kelvins. And that's our temperature, and pressure is in atmospheres, 2.04 atmospheres, and that's exactly where we need it to be. So that's good. All right, so we're working with PIV, PV equals nRT. We want volume alone, so it's going to be nRT divided by P, and we can start plugging stuff in. So 0.151 moles, and R we know is 0.0821 liter atmospheres mole Kelvin, and temperature is 331.2 kelvins. All of that is going to get multiplied together and divided by the 2.04 atmospheres. And when you do that, moles are going to cancel, kelvins are going to cancel, ATMs will cancel, and that leaves you with liters. And we end up with 2.04 liters. Does that make sense? Okay, a small amount of moles, pretty low atmosphere, and that's a low volume. Okay, temperature is fairly high. So that looks good, and that's that. All right, let's do the next one. This time we have at what temperature. So T is our unknown. Does 16.3 grams of nitrogen. So that means we're going to have to do a little calculating for N. 16.3 grams times the 28 grams over 1 mole. And when we do that math, that ends up being 0.582 moles of the N2 gas. And it has a pressure of 1.25 atmospheres. That's supposed to be a 5. And volume is equal to 25.0 liters. Okay, so we again start with PIV, PV equals nRT, and we want to isolate T by itself, so T is equal to PV over N and R. Pressure 1.25 moles. And volume is 25 liters. Divided by N, our number of moles, is 0.582 moles. And our constant, 0.0821 moles, liter atmospheres per mole. That should be an O. Kelvin. My pencil is delaying on me. Okay, and then our mole will cancel out mole. Liters will cancel out liters. This unit's supposed to be ATMs. Hopefully you caught that mistake. That should be ATMs, and then moles gets canceling moles, and we end up with Ks, which is all we get. And when we do that math, we end up with 654 kelvins. Okay? And if we look at that, we have about a half a mole. Our pressure's up a little bit. Our volume is up pretty good. So that looks about right when we do that together. Okay, and that's it for the homework problems. We have one last bit left, and that is the combined gas law. So next video will be the combined gas law and the 2 example problems that go with that. All right, see you soon.